Welcome to Between Data and Risk podcast. Today we'll be talking about making AI and machine learning models explainable. To discuss with us the practical methods of achieving this, we've invited Serg Masis, data scientist specializing in agriculture with a background in entrepreneurship and web app development, and the author of the book Interpretable Machine Learning with Python. Stay tuned.
If you're a business owner or senior manager, you probably had more than enough about all the wonderful opportunities awaiting you in the era of digitalization.
Whether it is big data, cloud, data science, or whatever buzzword is currently trendy.
If you would like to hear someone dissecting these claims and showing you what it actually takes to improve business processes, you're in the right place.
This is Between Data and Risk, where we discuss real-life examples of what works and what doesn't in the world of business operations.
Hi, I'm your friendly neighborhood data guy, Dr. Marian, and with me is my co-host, Artur Cognition Shared Solutions Chief Risk and Strategy Officer.
Hello.
Welcome to this episode of Between Data and Risk. Today we'll be talking about how to explain results produced by AI to someone who is not an expert in the field. And we're excited to have with us today our guest, Serg Masis, data scientist and the author of the book Interpretable Machine Learning with Python, an expert in interpretable machine learning and explainable AI, who agreed to share his experience with us. Hello, Serg.
Hi, how are you?
We're excited to have you here.
Thank you. Same here.
So we spoke for a couple of episodes. We mentioned explainable AI, and Artur just couldn't wait to hear what it is. It's a topic which we covered, and I was unable to do it.
I'm not an expert, right? So when Marian, who is a data scientist, talks to me about AI and the results and how you can achieve this, and I'm a risk manager, and in my mind, I always think, how do I actually substantiate the result? So to me, AI and deep learning neural networks, they are just black boxes. Data goes in, and the result comes out, and no one really knows why. So why is it so hard to explain the result? Where's the problem?
Well, imagine a machine. There are different levels of machines. There are machines that we can intuitively understand because they're we see the mechanisms in front of us. It just move, right? So maybe it's the case of a stapler.
Mm-hmm.
Everybody looks at a stapler and they know exactly how it works, right? But then compare a stapler to a rocket ship, right? That's the difference between a linear regression model and a neural network. There's a lot going on, especially a neural network, like one of these large language models. You probably heard of them, GPT-3, BERT, and all of these ones that are used. DALL-E, which is already like a text-to-image model. Like these have trillions of parameters. So exactly, it's like the moving parts. You go and ask, how many moving parts does a spaceship, a rocket or something have? It probably has a lot more than your stapler. So it all has to do with that. Understanding that is really complicated. In a model, it's different because in a model, it's like something's coming in and something's coming out. So and so you have understanding a model is that understanding that process. And so how do you understand the process when it's a really complicated machinery? And the reason it works is because it's really complicated. So the solution is not saying, oh, let's make it more simple. Sometimes that can work, sometimes it can't. In the case of a language model, well, language is complicated, right? A large part of the human brain is devoted to language for a reason. It's one of the most complex things we have to deal with. So that's why it gets like that. So we have to connect those dots, and I'm probably getting ahead of myself, but that's pretty much the gist of it. Why it is complicated.
But as someone who has spent the last 20 years in financial modeling, a lot of the mathematical models that we used in finance were quite complicated, were multi-layered,
Mm-hmm.
but they were analytical, or Monte Carlo, and yet there is always the kind of explainability that is achieved by running different cases and seeing how the model behaves under boundary conditions.
Mm-hmm.
Can the same be applied to neural networks, machine learning?
Absolutely, and it should. I mean, we shouldn't just stop, and that's part of the premise of explainable AI. At least for me, of course, there's all the ethical reasons why you should use explainable AI, and they may have to do with fairness, it might have to do with consistency, but then there's a very strong business reason and technology reason. You know, we have to trust technology, we have to trust business processes that rely on technology, and therefore, it's just a question of having a product that is trustworthy, right? At the end of the day, is be able to assure stakeholders that, you know, their model is not going to fall apart. You know, and there's different levels to it. Of course, if you have a once in a decade or once in a century situation that's never happened before, you can't expect your, you know, like your trading algorithm to work the same way. It's never seen anything like that. But what you could do is simulate those processes and say, well, it can work in these conditions. After this, it shouldn't. And then you can put guardrails in the system, making sure that if that happens, you know, it tells the end user, hey, there's something going on. I can't give you a good result, right? Or the confidence intervals just expand to the point where it's like no longer, you know, useful to the user, but at least it's telling it, you know, like this is unforeseen territory. So I advocate for the same where I work. I work with agriculture, and I've been advocating for a while, like we need to put guardrails on these models. If we have a once in a you know, generation sort of situation, you know, like with a drought or a flood or something like that, like we can no longer predict with any sense of accuracy what the farmer is going to encounter.
and it seems like, you know, over the last few years we've lived through about, you know, one once in a lifetime event per month. So
Yeah.
we've had a fair share. But I want to kind of, before we get into how you explain AI and the methods, I want to kind of dig a bit deeper into maybe it's a myth, but to someone who only kind of explored AI and machine, like deep learning as a user, I want to kind of understand, maybe there is a kind of user sourced wrong perception that AI is unexplainable, because it is being marketed as, and we talked with our previous guests a lot about how AI is marketed and mismarketed. You know, that maybe it's sold as something that is almost magical. That you put your with DALL-E, you put your description in, and magic happens. A lot of numbers get crunched, and a beautiful picture comes out, or as the case may be, a splodge on a dark background, and the kind of providers of these technologies don't really want to provide an explanation, because part of the mystique is part of the marketability of the solution.
Well, I think we have to lose that mystique. It's part of the, like when I started in web development, there was a certain mystique to web development. You know, I'm talking 20 plus years ago. It was like, whoa, you're working with the high tech stuff, right? And you know, like it's just HTML. It just seems like it's you know, like something out of, you know, like to be able to make these things that are seen, you know, anywhere else in the world. That wasn't really my magic. I was just piggybacking on other technologies that existed before. And that relates to also a point I make when I discuss this topic. I tell people, well, this is no different than flying was in the 1930s and 40s at the beginning of commercial aviation. For some time, it was just like something like only certain like organizations leveraged, you know, like the postal service and military and so forth. But it wasn't like no commoner would get on a plane, right? And it was also a thing that hobbyists did, and they took a lot of risks. and you would see them dancing on planes and things like that, right? We still in that kind of Wild West kind of era of AI, where it's still seen as something magical. And I still think it's like that with fortune telling. It's unnatural. Like, that's the equivalent of predicting. It's unnatural for humans to be in that realm, right? In the same way, it's unnatural for us to be in the sky flying with the birds. That's not our territory, right? So I relate those concepts because I think, well, we have to reduce the hubris. Like, I don't think passengers have to know exactly how the plane works, but they have to trust it. And we have to make sure that the way they trust it is that we don't buy our own hubris. The people that work in the aviation industry, they know how delicate everything is, which is why they take every time the plane lands, they make sure it's like everything, every bolt is typed, everything is like in working order. They measure every metric, right? They go through all this process because they realize that the planes are delicate, right? And we should do the same with the machine learning models. We should realize that they're not perfect. They can fall apart. We need to be on top of that, not only while we're making them or training them, but also while they're doing their predictions, right? So we have to be on top
especially
of that.
while they're doing their prediction, because when
Exactly.
you're training them, they're still in a controlled environment. When you let them loose, that's when they start encountering, as you said, things they've never seen before, and anything can happen.
Absolutely.
Correct me if I'm wrong, Serge. When I'm trying to explain to people and demystify machine learning, it's like, if you had, I don't know, a soup every Tuesday for the last 5 years, like, we can predict that, next Tuesday you will have soup. And actually, that's it. The conditions change a little, the number of variables changes a little, or a lot, but in the end, it's about recognizing the patterns in the past and applying them to the conditions in the future.
Yeah.
And we had a pretty interesting discussion about what AI actually is, and that there is no single definition of AI. I like that you called your book, it's Interpretable Machine Learning. It's like, out of curiosity to maybe get another opinion, like, how would you define AI? Because let's say that we are business people and we don't know, and we have this vendor coming to us and saying, oh, we have this AI-powered solution. To me, when I hear AI-powered, I'm getting a bit itchy. Like, I have a feeling when somebody tries to sell something to me without really trying to tell me what it is.
Yeah.
I consider it about AI for today. I consider it a smoke and mirror, but that's me. So I would like to know your opinion on current status of AI definition and how much of a marketing buzzword it is applied to some machine learning, anything more than one if else, and how much what you can expect from AI, really, from the business perspective or a user perspective.
Yeah. I think AI is, definitely a loaded term. It's definitely also a buzzword, but we mustn't forget that for end users, and I'm not talking business leaders, people that probably should know better, it's the only kind of concept that connects with what we discuss when we talk about machine learning, right? We tell them machine learning, they don't know what we're talking about. So it's a bridge, right? So it's captured the public imagination. It's not like we're necessarily exploiting it, but it depends on the audience. If we're talking to business leaders, other technical people, let's call it what it is. For the most part, it's machine learning, right? That's what it is. So I don't, since my book was for technical people, I don't use AI in it. Yeah, but if my book were for non-technicals, AI, I use ML in it. And if it were for non-technical people, I probably use AI because it's the only thing they would connect to. If I call it machine learning, they think it's, what the hell is this? They don't know. There is no also a lot of people working in the space in like non-technical capacity. I'm talking AI ethics, technologists, that aren't necessarily technical, right? People like that, they still relate to the term artificial intelligence. They may complain about it, especially AI ethicists. They complain about the term. They say it's ridiculous, but that's the term they latched onto. They don't call themselves machine learning ethicists. They call themselves AI ethicists. So, I mean, that's even politicians, when they talk about it, they won't talk about machine learning. They'll talk about, so we have to reach some common ground. To me, the definition is really close to machine learning. It's just simply something that is autonomous. It's not necessarily intelligent in the broader scheme of things. It doesn't embody at this moment in time any kind of
consciousness.
Yeah, anything like that. It's just a narrow intelligence. Even the most quote unquote intelligent machine learning model is not intelligent, right? It just has some ability, very narrow ability to do something that might seem superhuman,
detecting the patterns which human eye can't, and then there's the reacting to it.
And that's, to me, like the minimum like requirement for AI. It's software that is autonomous to some degree, and software I say here with a very broad stroke, because I don't think AI necessarily is software in the fullest sense of the term. However, I do think it has a lot of the elements. It's still ones and zeros. It's still a program. So we didn't program it. That's the big difference, right?
Mm-hmm.
But I think it does have, since it has a lot of the same mechanisms that we don't fully understand, we kind of put this responsibility on it that it's necessarily much better than everything else. It's not, and we should be cautious with it precisely because we didn't program it. But on the other hand, the bare minimum requirement is that it is at the very least at human level capacity or more. Otherwise, why the hell are we using it? We should be programming something with if and else statements and traditional programming if it's not better than that.
I have another question, because let's move to explainability a little. You said it's like we have a rocket.
Yeah.
Most of the rocket didn't design itself.
Yeah.
It's not that I'm a rocket scientist. We had an episode with someone who worked for NASA, but I can't remember them, let's say, arranging, internal parts of the rocket by the rocket. So how do you explain AI and from the user or a business perspective? Like you have this machine learning / AI model, and it says, it will predict sales of your product. Just plug it in and prepare as many shoes as it tells you. How can I demand, or what can I do, or should I expect? For the question, okay, how does it know? What are I don't expect someone, if you mentioned DALL-E, I don't think any business owner would like someone to walk over through all the layers of the neural network behind. It must be something else than just a drawing of million layers deep network, or isn't? Or what really is explainable?
Okay, yeah, it can happen on several levels. There is actually two concepts there, and depending on who you talk to, you'll get a different perspective of what they are. There's explainability and interpretability, and some people like to call interpretability what explainability is, and vice versa. I'm of the camp.
Let's try to sort them then, and
Okay.
We invited you as an expert, so let's rely on your word on it. And it doesn't. Artur, as a risk manager,
what's the difference between explainable and interpretable?
Okay, well, one of them has to do with be able to go deep enough to understand every mechanism of the machine, right? And it has a very stringent, depending on who you talk to, they might say, well, you have to understand everything holistically. Like you're able to see it as like a mathematical equation, understand, okay, this is what happens. Once it gets too complicated, you can no longer understand it. I mean, holistically, right? So that is very stringent idea. I don't agree with it 100%, right?
Correct me if I'm wrong, but the last processor, which is like mathematically proven to be correct on its operations, is I think 𝑖386, and everything.
386. Okay, yeah, you're talking about floating point number precision.
Too, but like the processor, the architecture of the processor, where there was a mathematical proof that if you opened all the gates, and it was a mathematical model that you open. You could use all the logical gates inside, and whatever you put on one side, it was explainable what goes on the outside. Anything more complicated, that I think it was designed in 90s, it's too complicated. There's no mathematical proof that your processor will give you the right answer if you provide it with
I think that's a limitation from digital architectures.
But people use it.
I do.
People use it.
I do.
Right.
I do. And I've been advocating actually for very exciting news. I think I posted about it LinkedIn some while back. There's a lot of new research in analog processing. That is having matrix multiplications happen completely on an analog level. Because after all, like the signals we use, the electric signals, they're not like ones and zeros. They're actually come in, like different continuum. There's a continuous nature to them. So you can do simple mathematical operations using the physics of the electrical signals. So there used to be, all computers used to be analog, and then they kind of gave up on that. But that's kind of a side note. So I think what you were saying about that is very useful, because I think like we have to abstract things as human. We have to be able to abstract things, otherwise we don't understand it. And some of the part of the reason that we actually fall trap into our own ideas and our own lies, and there are often contradictions between a lot of these things, is because we can't look at things at that level. We can't holistically understand everything, right? So we shouldn't expect that from models that model pretty much the most complicated processes in our environment. Be that distinguishing between different kinds of animals, or like between different phrases in language, or whatever it is. These are complicated. Or even the generative art. Like how do we ask an artist to tell us what inspired them? There's always going to be an abstraction. They're going to tell, oh, I was inspired by this and this, but they can't possibly tell us the step-by-step process they took to make the art they made. So like we can't expect that from our models either. So that's why I think there is a lot of promise in this idea of post hoc interpretability. And that's the kind of explainability I've latched onto, which is not the truest sense of explainability, because as I said, explainability, again, it depends on who you talk to. They'll say explainability is you have to know everything about the model. You have to know how everything was made, right? From start to finish. And you have to understand it holistically. And to them, that is explainability. Or in some cases, that's interpretability. But for me, it's the other way around. I think interpretability should be used for things that we interpret. Much like you interpret statistics, doesn't mean you know every single data point in the chart, because you don't. But you know how the trend is going, and you can say, okay, if you draw a line here, that's an interpretation. Someone might come there and give you a different interpretation. And we've accepted that. The whole statistical community has accepted that to be okay, right? So like we shouldn't uphold machine learning models to a different standard that we have to other kind of elements in the data world. So that's why I advocate for post hoc interpretability, and I call explainability like the more like fundamentalist view of, okay, we have to understand everything. And that view is okay for some cases. I think it makes a lot of sense for a lot of very serious, situations, like where we're developing a model for like predicting diabetes. And so we have to understand everything because we don't want to put anybody at risk, that sort of thing. Perhaps in cases like that, or for credit ratings, things that have more serious consequences, but to a certain extent, because I believe in the power of human interpretation. And I don't think we should decouple everything. I don't think we should be irresponsible and say, okay, let's give the machine all the responsibility, right? And let's just let it work. I think humans should be in the loop in many circumstances, and they should not like delegate that responsibility.
But isn't that the promise of AI, that you can take the human out of the equation and get the same or better result? Actually, a better result is promised, specifically because you take the human bias, the human weakness out of the equation, and you move from predictive to prescriptive analysis and results, where the AI makes the prediction and then makes a decision and implements that decision much faster than a human ever would. Because you gave some very good examples, and we like being practical on the show here. So if you have an AI or a neural network or some other kind of machine learning algorithm that interprets medical scans to find cancer, or interprets test results to predict diabetes, you have a doctor who looks at the results from the algorithm and then like double checks, second guesses almost the algorithm. And then I fully agree that having that interpretability is very good, because the doctor doesn't have to repeat his the analysis in parallel. They can just kind of check whether the algorithm actually makes sense. But isn't the whole goal of playing this game to have one day an algorithm will be able to do the testing, the analysis, and then prescribe the right meds without human interaction?
I think that'd be in many cases very risky, and I think the value is there. Like there's been studies done in medical cases that having the human in the loop actually improves outcomes by I forget what percentage, and it varies from case to case. But the point is, it does speed up the process because they don't have to do the interpretation. It gives them more information that they would have derived. Like for instance, the model might respond something like, okay, this person has these 5 risk factors. Their scans show this image, and in that image, in this particular spot, there's indication of a tumor, right? And here in this other part, an indication of another tumor that they didn't even know of, right? So then they have extra information they wouldn't have had. They wouldn't have spotted. So they say, okay, let's do something. In a way, they'll then take that information and say, I want to do more scans. I want to kind of zoom in this area to see if it's true that there is a growth of a tumor somewhere else. So that will give them that superhuman ability. But if you left it up to the machine, they won't take any secondary steps, right? And even if we enabled them to do that automatically, which would be great, it still won't necessarily stop them from, missing out on something else that only the human would be able to detect. So I think there's always going to be a need in those cases. Like where I think it doesn't defeat the purpose is in a lot of other menial kind of cognitive tasks. Like will robots take, driving, absolutely, is something completely machines could do, right? There's other cases like factory working, semi-cognitive stuff like checking if there's some damage in some kind of fruit or whatever it is being packaged, right? A machine could do that a lot better, and we don't need to have humans in that loop.
But let's get back for a minute to this interpretable models. Like because we moved very deeply into medicine, which is very fascinating. But I'm sorry, I'm a boring guy, and I'm trying to get back to business. So let's say that I am a business person. I have my predictive model. It tells me you should prepare so many pairs of shoes to be sold. Like as a business owner or senior manager, if I would like to get some interpretability from the vendor, like what can I expect of him? What he should be able to explain to me in the terms of your interpretability. I don't expect him, and I don't want him. If he's a fundamentalist, he can understand his model, and he can play with all the zeros and ones in all the hidden layers. But he comes to me, and I would like to, as you said, have this post hoc interpretability. What does it mean really for me? Like, what should I expect? I don't want to get just one number. And what should I expect realistically, and what I shouldn't really expect?
Okay. Well, businesses often concern themselves with things that are of possibly they know, and they've known for a while, it can increase their profits. Forecasting sales accurately, be able to detect any supply chain kind of optimizations, be able to understand what kind of things they can improve on with their vendors, with their suppliers. What kind of also cost sensitivity of the customer. There's a lot of different areas that can be improved, and they can understand, like, if I'm an AI vendor for a business, I can show them not only, okay, this is the prediction, but I can show them why, and maybe it can help them trust the system a lot better, and it also can help kind of reinforce ideas that are maybe counterintuitive, but they actually kind of contradict the bias. Because, like, what I found in businesses is that businesses tend to have a lot of people that are kind of it's like the principal agent problem. You've heard of that problem in economics? So you have the principal as a business owner, and his shareholders and anybody that's just deriving direct value from the business, right? And then you have the agent, and the agent could be it could be a supplier, it could be an employee. So you have a lot of contradictions there, where you have salespeople that get their value from commissions, right? So the way they make sales projections is completely based on their own interests and not interests of the business, right? So if you have kind of an external system create those projections instead of your salespeople, then you don't have that. But if you have both competing, then you have something of you have an incentive for them to improve their projections, which you otherwise don't have. So I think it in a way it helps things make things more honest.
But still,
you yourself kind of mentioned that you need a human there, and if but here, if I understand correctly, you kind of implicitly assume that the prediction, which is unbiased, and again, it's an assumption of an unbiased prediction from the machine, it will be probably biased by whatever learning data that has been fed into it, because that's another thing. Being a risk manager, I'm very much in favor of having a double check and a triple check on everything. But by saying, like you said a minute ago, that human element, human check gives a better outcome, doesn't that kind of almost indicate that the machine learning algorithms, the AI implementations that we have now, are still too weak for complete kind of autonomous implementation, and we should develop them until they are actually complete?
Well, they'll never be complete, because it's an incomplete solution to it's incomplete. You can't fully understand the problem. Like, If you're saying, well, I want to forecast sales, like sales is completely contingent on the environment. It's contingent on the economy. It's contingent on supply chain. It's contingent on whether your employees will get sick. At any given moment, whether they'll find better opportunities somewhere else. Like it's really hard to predict those circumstances, even with all the data you have, right? And there's a lot of data you couldn't possibly get. So even if you came up with the most sophisticated machine learning model, and you put in like everything, you put in like past sales, like your competitor sales or your competitor stock price, whatever you want to put in there, right? Everything, right? And then you came up with a prediction of what your sales would be next month. It's still not encompass other things that you just simply couldn't have possibly anticipated, and you have no data for anyway. And a human would have that, but doesn't necessarily mean that a human would leverage it.
How would a human have that? If a human has that, you can feed it in a computer, right?
Well, yeah, but it might be like a one-off thing. Like for instance, like a human might know, okay, well, next month, like we're having, like
hurricane.
There's gonna be, well, that might be in the model, but they might be an event. Some event is happening, and it's the first time it's happening. Like say a big like conference or something, and it's happening in a competing territory or town or something else. And so in some way that's going to influence your sales. Or maybe like the competitor is going to release a new, product that's going to, like overshadow yours. So that's like a one-off thing that's going to impact your sales. And that's going to happen, but you're not going to give that to the model. How do you give that to the model as a thing? Like you would have to kind of, you might be able to kind of have it as an additional influence. Like you have some kind of weighting system where you score something as a risk and you feed it into the model, but it's like a one-off thing. It's not its own variable. So you'll be able to.
And I think that brings us back to kind of boundary conditions, because like you said, we can define a boundary condition and we say this model works unless there is a big event going on which will disrupt the normal working of the market. Because this is exactly what happens in high frequency trading, right? In the markets these days, they have models which trade semi-autonomously with breaker circuits, circuit breakers that can be engaged if the operators detect abnormal market conditions, or if the algorithm detects abnormal market conditions in certain cases. But apart from that, the algorithm works, and a lot of them are based on very complex implementations of machine learning. And in this case, we give almost full autonomy within those defined risk envelopes to the algorithm, because the algorithm does hundreds or even thousands of transactions every second, which would not be verifiable by a human by any means, right? So it is, I think I agree with you that we need to define those envelopes within which the model needs to work, and it will be fully explainable, or at least sufficiently explainable or interpretable in that envelope. If it steps outside of it, then we kind of know that anything can happen. So we just stop it going outside the bounds where there be dragons.
I'll be boring, I know. But I will drag back. So we have our shoe sales, and you mentioned that you should be able to ask our vendor why. The question is how far in why, asking why, we can go. Like, do you have an example? Like what could be explained and what never could? Like we know that these one-off examples are unexplainable. Like we have some events which will influence our result, and we will miss the reality by a big margin because something happened that we can't feed into the model possibly. But let's assume like a good old situation. I'm selling shoes or Christmas hats, and probably taking into account time of the year is a good idea. like how far we can expect in asking the question like why?
It depends on the data that your model was trained on. Like say you had the shoe sales model, and it's trained on I don't know 20 different variables, including past sales, weather details, like
Birth rates,
economical indicators, of how the market is right now for not just shoes but everything in general, and
of
perhaps
course.
maybe even other things like the cost of leather, right? And okay, so you have all these things, and you feed it to the model to figure out what is your sales going to be next month, right? Based on sales of I don't know the last few years and on all these indicators, right? So what you can have for a model like that is be able to say something like, okay, I'm predicting higher sales next month because it's December, right? Or it's November, and you expect good sales, and so it will tell you it's November, and that could be something that anybody could probably figure out in their head. It's people are giving out gifts, so it's a good month for that. But maybe it could tell you something. Well, it's not as big as last year because there's a recession.
The leather prices are a bit higher,
Exactly.
and inflation is a bit higher, and actually it's a pretty warm autumn, and people use their shoes a bit less.
Exactly. So there could be a number of things, and if you could break this down into different kind of categories, and if it was just you have your boot sales, you have your high heels, and you'll have different reasons for each one to be selling more. That would probably be the smarter thing, because then you'll be able to say, well, the weather is going to be mild next month, therefore boot sales are going down, and it actually there's there's more people graduating out of university next month, so you're going to have an increase in high heels or and like formal wear or whatever. So you'll be able to probably engage with it better if you are more granular. And that's my general idea of what it is in machine learning models. It's better to go granular, maybe not too granular, but just enough that our data will allow, and also with the errors, which is an important thing. So when we evaluate the models, if we dig deep into this is where it's having a problem with these this kind of population of the data, right? So it's really good at predicting boot sales, but it's terrible at predicting high heels. Why is that, right? So you're able to look into that.
So if I'm a business owner and I hear about this interpretable machine learning, explainable AI, I know very little about this, and I can think of at least 3 ways that I can get this, because I want to get, as a business owner, my hands on it. One way is potentially maybe I need to employ a data science wizard who will do the work and explain to me why AI is giving the results that it is. Another is I need a second product. I need to run my AI, and I need to run a parallel product which will explain this AI. Or I need a different AI. I know, Marian, that you're shaking the head because I don't know, right? A third way that I can imagine this running is I need a different AI. I need to check out my non-explainable AI and buy a new AI that will be explainable. So which of the 3 ways is actually what works?
None.
Okay, so how does it work? How can I get my hands on it?
All three that you mentioned. Sorry, Serg, for cutting in, but I can't contain myself. All the three methods that you mentioned that you could imagine have common denominator. They work on the outcome.
Okay, so
and you can't explain how the outcome was received if you are not observing how it is being made. It needs to be built in, like a resilience into the company.
So it's the third one, right? That I need to buy a new explainable AI.
No. You need to buy explainable AI, the one that you are using. The one that you are using, you need to buy explainable AI with which will observe what it is doing, how it is
but
doing.
I already have AI. I invested in
And you will
AI.
not-
I have this non-explainable AI, so I need to check it out and
you're
buy a new one.
lost. No, yes.
Well,
Yes,
you
cannot-
can you can take what he got and do post hoc interpretability on it. It's there is the possibility of getting something else that is more explainable, like another kind of algorithm, like maybe there's one called explainable boosting machines, or other ones that are like high precision rules, like figs or something like that. You can get a model like that and train it, and then you'll have, at the end of the day, you'll have something that you can probably explain with a lot more fidelity. But you can take even something as complicated as a neural network and do post hoc interpretability on it. And what it does, it kind of assuming you have access to the model, it retraces the steps on the model to get to possible to get a possible explanation using what is called the gradients of the model. So you could use something like integrated gradients, or there's a bunch of different methods to get to the bottom of that. And you can do it for all kinds of for the entire data set, or you could do it for an individual case. So you could say, well, say you have a credit, you built like a credit model, one that assesses if a customer is going to have certain risk or not, and then you can use that to get to a prediction.
But
a
without
prediction,
access,
I mean an explanation. So an explanation
without
could
access, without access to the code, to the actual model.
That's the thing. You would need access to the code, to the model.
To the model. That's what I'm saying. But
to
as
the
long as you're
weights of
working
the
on the black
individual
box,
layers, you would need internal access to the individual layers, the individual neurons, gradients.
Then you can interwoven it with some external. But what I meant is, like, if you just have results, if you just get 5, getting why this machine answered 5 requires actually recreating it. So building something which will be this identical machine plus interpretation model. So if you can chuck bits and pieces. Correct me if I'm wrong, Serg, because
you need access to the model to do most methods. In the absence of that, you could use there's some permutation-based methods. I mean, you might not have access to the code of the model, but you can query it. And there's permutation-based methods called CHAP and LIME and everything, and they
recreate the model yourself.
Yeah, it's like you're accessing the model and you're sending it in different signals that are similar, but they're not quite what you're trying to get at. And then they'll give you it's like sensitivity analysis. Have you heard? It's something like that. And so it'll be able to tell you, based on those permutations, what your model is, what's the reasoning behind a certain prediction. Because it's able to say, well, say for the credit case, it's able to change the prediction, be able to say, well, if I increase my my collateral by this much, then it predicts no risk. And if I decrease it, it predicts even more risk. So this must be an important variable, right? This must be one of the reasons. It does that for every variable, and then it realizes, guess what? These are the variables the model finds to be more important, and this is why. So it kind of finds these monotonic relationships. But we were just earlier discussing like neural networks, and for neural networks, like the best case, since they're so complicated, the best way to query them is actually through access to of the model.
So it kind of almost reminds me, back in my university days, where I also was forced to study some electronics, and we did have this kind of case study where you have a black box circuit, and instead of trying to disassemble it and find out what it does, you kind of put different signals in the input and find out what the output is and try to rebuild it, kind of reverse engineer it. So if I understand correctly, you're talking about similar reverse engineering of the model, trying to find out where it reacts and how it reacts in very specific cases, and then building up a bigger picture. And I think it at least two separate use cases for this kind of investigation are applicable. One is when you're testing the model, when you're actually designing the risk envelope that we discussed, because you need to be able to find out where the model actually goes wrong, and at which point it's the boundary of its applicability ends. And then the second is obviously, as you kind of gave the example with the credit score, when the customer actually suddenly gets refused credit, and they come asking very pertinent question why. You have to be able to say, in a lot of cases, why exactly that decision was taken, right? You have to substantiate.
Sounds about right.
Okay.
So how would a business then apart from this, have you had any practical use cases of where explainable AI, have you seen it used in the field?
Yeah, I use it in my work. I work in agriculture, and I need to be able to explain why the models predict what they predict. Not only to the agronomists for whom I build the model, but also for the end user, which is the farmer. The idea is that you'll be able to tell the farmer, well, I predict there's going to be high risk of this disease, and tell them exactly why, because otherwise they won't trust it just as much. They might say, well, in my experience, it doesn't seem like it. It's not the right time of year for this. But then you tell, well, it's the humidity of this period, and then combined with, the fact that your neighbor had it, things like that.
I guess every model can be more or less explained. Like when you have sales, you would like to understand why the prediction of sales is such, because then you can try to, counteract. If the prediction is that your sales will drop, maybe you should increase your marketing. In example, I didn't ask for shoes completely without a hidden agenda. It's just we used these models when I was working with marketing teams. We use this modeling to be able to influence and predict when the sales will drop, because market could be pushed a little.
Market manipulation in shoes.
That's the interesting thing about models, right? They don't happen in a vacuum, as you said. Well, we can make them in a lab environment with all this data, but out in the field, they influence the outcomes that then later become part of their training data. So you can create models that actually make the conditions worse for it. And what I mean about that, well, it's if you there's cases of where it's happening for bias, where you actually predict people to not be good for credit, right? And then it becomes like a self-fulfilling prophecy because you're not giving them any credit, right? The same can happen in cases where you say you have a marketing allocation model, and the way you're actually influencing the market impacts your marketing budget even worse, because you're somehow increasing prices, and you're not evaluating that because you're not focusing on how your model will influence the market. You're just trying to beat the market, right? So you have to understand it's all part of the same system, and as I try to say, well, like we're often focused on predicting the future. That's our job in my field. But I think, well, why not predict the future that we want, not the future that we, that's the best thing. We can influence the future, and that might seem like a silly thing. That's the best way of predicting, because like if you can influence the future, then you're predicting the future that, it's going to align, right? So I think the problem is, like, there's a lot of bad data because the data has already been tainted by us. We have already tainted the data. So we have to have that skeptical view of data as something that is not pure. It's not like we have already tainted it, we have already dirtied it, and so we can do what we can to take the part of it that can lead to the predictions we want.
Okay, and this is a completely separate but no less important topic, getting the data right. And I think we should kind of tackle it in a completely separate discussion. And this was, I think, very practical for anyone who is involved in AI in business, because very often the discussions are, how do you explain the results to a client, to a regulator, to an auditor. So this should give at least some overview of this. You have published your book, so for anyone who's a bit technical, they can obviously reference your book. If someone wanted to learn more about the kind of maybe higher level concepts, so where can they? What's the best kind of? Do you have a resource they could access, or they could reach you?
Yeah, certainly. Well, if they want like a higher level access, there's a ton of books that talk about AI and how it works. I don't know them off the top of my head, to be honest. But I personally like, they're a lot more like doomsday, right? But it is interesting. I like to see it through the lens of bias, because perhaps if they have this view, they understand why it's important for us to evaluate models. But I like the book on weapons of math destruction. Is a good one.
Oh yes, we quoted it very often in this podcast. Yeah.
Okay, and probably people that are less that are more like like in the business or economics realm, finance. I like the books from Nassim Taleb.
Yeah.
Nicholas Taleb is his last name. So I like pretty much all his books. Yeah, but my favorite is The Black Swan, because it is also a good like foray into why we shouldn't trust ourselves. Also a lot of books on behavioral economics do the same thing. And there's just so many from Thaler, there's just so many good authors in that space. And I think that's what I would recommend before getting into AI, because I said there's a lot of hubris in the space, and for us as practitioners, I think it would be the worst thing for someone to enter the space as a practitioner, say they have software engineering space, and not come with the skepticism and have all like the idealism of that they see from TV and the robots and they're going to take over and all that stuff.
Marketing adverts and
well, let's hope they do get, because we get so much AI, and I've got a toothbrush that is AI driven. I hope it doesn't strangle me in the middle of the night. Thank you again for giving us an insight into this topic, and as always, let's hope it was of use to someone.
Thank you for listening.
For more information about making models explainable, make sure you check out Serg's book, Interpretable Machine Learning with Python. As usual, the link will be available in the notes to this episode.
Also, don't miss the next one, where we will be talking about metaverse and ways it can add value to businesses. To discuss with us different aspects of value in metaverse, we've invited Nicolas Babin, a serial entrepreneur, executive and board member who has spanned startups to multinational tech giants with experience in Asia, North America and Europe.
Subscribe on your favorite podcast platform or visit bdr.show to find out more about future episodes and guests. You can also check out cognition.lsd for more information on Cognition Shared Solutions, our services, and other events hosted by us.
For now, it's thank you from myself, your friendly neighborhood data guy, Dr. Marian, and my co-host, Artur.
Thank you.